Welcome back everyone. So I've been doing some Blender videos for a while and I thought it would be time to do some more Unity stuff as well. So I'll be mixing things up, but do some more speed modeling and things like that. I hope you watched that last video that I made. It was a Star Destroyer that I put together in 10 minutes. It freaked me out a bit time-wise and now I'm going to try to up the game next time. So if you remember from last summer, I released some videos about a platformer project I was working on. Had a bit of fun with this robot guy running around platforms, shooting things up. I was using some inverse kinematics there for the arms and the aiming, but I used a third-party asset called Final IK, which also has a plugin for aiming IK. And that's a really good asset, and I do recommend using that one. But I also had a YouTube visitor, a fan, subscriber, I don't know, Matt his name is, and he suggested that I'd make a video about doing some inverse kinematics aiming from a platformer perspective. So since I had some of the code already prepped, I thought I'll put together a video about that, a bit of a how-to, and I want to be able to do it without using any third-party assets as well. So in this video, I just I've modeled a little cowboy guy. You can see him on screen now probably. It's just like a really basic low poly, and I rigged the character as well and did some simple animations, did a walk cycle and just some like an idle stance and some gripping and things like that, aiming. What I'll do now is I'm going to bring that into Unity and then have him just run around a little bit to create a simple script to have him go left and right on the screen like a platformer and do some jumping. And then most importantly, I want to add the aim IK script as well. Not only just aiming with your hand at a target, but also looking at the target with your head. So I'll go through the process now. I'll be switching the camera around a little bit so I can do this properly, and I'll try to edit it so it's not going to be too boring and dragged out for you. Also, check in the description below. If you want to go straight to the IK part where I do the inverse kinematics, you can just skip forward. So I'll expand the little description below and click on that little hyperlink to the right position. I've actually created this project once before, and I've started a brand new Unity project so I can recreate the whole thing, so it'll make it easy for you to follow along hopefully. And but I will be dragging some of the assets that I've created from my old project in, but I'll talk you through the process. And again, if you want to see the modeling and the rigging and animating of a character, I don't have the cowboy recorded for that, but you can check my channel history and you'll find some videos about how to do that. So if you want to check those out beforehand, do that and then come back to this video. First thing I'm going to do, I'm going to create some tidiness here. So let's create a folder called meshes, and then I'm going to bring in this cowboy that I created. And basically, it's an FBX file that I created in Blender, and it's got a few animations here as well. Like the only ones I'll be using now really is the walk here, like a walk cycle, and also the idle pose here. I'll be using that one. That's pretty much it, I think. The rest I'll do with inverse kinematics. Let's drag him into the scene straight forward. That'll just create him here. And then I also prepared just a simple material texture here. So let's create a new folder here and call this one materials. So I'll include textures here as well. And I've got a simple PNG file here. As you can see, it's super tiny. It's only 4x4 pixels. So for that to work, let's actually create the material there first as well. So I'll right click here, create material, and then let's call this material cowboy, if I can type. And for this one, we need this texture. If I drag this on now, you see the colors are all funky, and that's because I need to do this with the texture. We need to switch to point because we don't want it to interpolate, and also we want to switch off compression to none, and then that's when the colors pop. It's because it's such a small texture that it's only these individual pixels that we need. I've also prepped here, so I've modeled a little pistol or a revolver and a hat. So I'll bring those two in by dragging them into my meshes folder here. Oh, I need to apply that. That's fine. So let's bring the gun in here and let's slap the same material on that one. And then we can also bring the hat in and put the same material on the hat. If I hold the Alt key and click here, it'll expand the whole hierarchy here. And what I want to do now is I want to put the hat onto the head. It does no good on the floor. So I'll drag this one up and put it on head end. And then here we just reset the position. And wham, the hat is in the correct place. And then same for the gun. We want to keep that in his right hand. So let's put it there. There we go. It's in his hand now. I just reset the transform there to 000 based on hand. We can move it a little bit there. So that's it. We've got it set up now. What we need to create now is an animator. So if I press play now, then basically nothing will really happen here. So we need to set this guy up. So, okay, let's add, we already have an animator on here, but we do need to create here. So we'll call this one, we'll create a new folder called Animator. And then we'll right click here and create a new Animator Controller and call it Cowboy Controller. Anim Controller. And double click that one. And then basically we want him to default into an idle pose here. And that's going to be the entry and the default one. We don't have to do much more to that at the moment. So, but we do need to click on the cowboy here and then drag this newly created Animator Controller onto the controller here. And now he is, oh, I have to do that when I'm not in run. So, because otherwise it'll reset. So let's do this again. Drag this one onto there. And when we press play now, then he's standing in his idle position. It didn't loop now, and it's because I've imported this cowboy and I need to go to the animation tab here, and then on the idle, I need to do loop time. Another thing we should do is we should switch this rig to a humanoid. Let's configure the avatar here. Everything's correct pretty much on the bones that I named on my mesh, apart from the chest is not defined. So let's pick the chest here. That one. Everything else is defined here. So that's good. Let's apply. Done. Animator. And let's press play again just to make sure. And it's now looping. So you can see that his feet are moving a little bit. That's a real pain. And what you can do to compensate for that is that you can go back to the animation and then switch off animation compression. That can help a little bit. Plus, we can go into the idle pose here, and then let's switch to original here for all of these, and then bake into pose for all the positions and rotations, and then apply that one. And now there'll be some less movements on his feet there. They're not. They do still a little jump, but it's not really going to be noticeable when it's in a platforming game like this. So we'll have to live with that for now. Okay, so we've got him in his idle position. Let's put a floor in here. So let's expand the sample scene here. Right click and create a new object. Let's just create a cube that we set in -0.5 here, a floor, and let's make it 20 wide maybe. And we can create a new material so it's not so white. Let's create a new material and call it floor, and then make it gray. Switch off some of the reflection here. Floor. Okay. And we can flip the cowboy around as well so he's facing the camera here. Before I get into the IK, I'm going to make him move. So let's make a little script here. So let's create a new folder called scripts. And then let's create a new script here and call it cowboy. And let's put that script on the cowboy himself. There's a few things that we'll need for this guy to move. We need to put a rigid body on him. And we need to put a capsule collider. And my character is about 1.8 meters high. So let's make him that. And then put the Y position here to 0.9. So that'll put the capsule like this. If I press play now, he should stand. That's good. And let's start some coding. So there's a few things I want to set up. For platformers, it's usually good to have a gravity that is higher than natural. If you use the normal 9.81 meters squared in a platforming game, it'll look like it's running in slow motion. What we can do then is let's just change this here. So like, let's go into project settings here. And let's go into physics and let's change this to -30. So trust me, you'll want to do that one. So unless you want a slow motion game. Realism is rarely good in a game. Make it fun instead. Okay, so we've got our cowboy script here, but a few things that we'll need is we'll do some public variables here. And the first one is we'll have a float, which is the walk speed. Let's do that initial default to 2.5 units per second. And then we do a public jump height we want as well. And we want the character to be able to jump maybe 5 units up in the air so he can make it to a different platform. And I'll be using Rigidbody for my platformer. I know some people use just transform translation. I prefer to use Rigidbody and applying some velocity changes, and also prefer to have this predefined jump height instead of just applying a random force. I want the script to calculate which height you should be able to achieve, and the script will compensate for that. So we'll get to that in a minute. Okay, there's another few things that we need, and it's a reference to a transform that we will call ground check transform. And that's because we need to be able to know from the script if the guy is touching the floor or not. In this, under the cowboy here, let's create a new game object, empty, and let's call it ground checker. Ground checker. Development like this. You want the center of the character's pivot point to be at the character's feet. So that's where we're going to put this ground checker. And as you can see now, this is exposed here. So let's just drag this ground checker transform onto the ground checker there. So that is done. We'll come back to that in a minute with the code. We need to set a radius here. So a ground check radius, and let's make that 0.2 units. Okay. And we can start. And then we also need some private variables. So let's do a private reference here to animator, which we'll be needing to send speed and stuff to the animator. And we need a bool here. Bool is grounded. We need to know if the character is grounded or not. And in the start here, let's grab these components. So animator equals get component animator. So in the start mono behavior here, we set up to grab that reference. And also we need the rigid body. So let's do a reference to that. Private rigid body, our body. Let's grab that one here as well. Our body equals get component. And the reason why I do that here in the start instead of always doing the get component is because it's much faster to save the reference into a variable like this rather than using get component in every frame. If you care about performance, don't use get component all the time. Just store the reference in a variable. In the update loop here now, we need to stop grabbing some input. So we need another float here. So we do private input movement. We need to store how we want the character to move. And then here, let's do input movement equals input get axis horizontal. So horizontal, let's keep it American. Since we're using a rigid body, I'm going to do the actual movement code in the fixed update, which runs on a fixed rate. And by default, it's at 100 Hertz, which is 100 times per second. So, and that's a fixed rate, and that's where you want to be doing your rigid body changes. So fixed update here, then we need to do, let's set the velocity now. So we need to do new vector 3, and let's grab this input movement, and then put the times, multiply that by the walk speed, and then we need to do, we want to keep the y velocity, which is the up and down. We want to keep that one to what it was before. And then the z movement, we don't want any movement at all. No velocity in the z, because the z movement will be depth-wise, so into the scene and out of the scene. We only want this character to be able to move left and right, which is this movement, left and right with the walk speed. And then we want to keep the current y velocity up and down. So let's press play here and see what happens. Okay, so he's moving left and right. So I'm pressing right now. He's obviously moving right. Maybe not the most graceful movement, but let's fix that. We can't have it like that, can we? Here in the rigid body, let's expand constraints. And then we want to freeze the position first of all. We only want it to be able to move left and right and up and down, not into the scene and out. So let's freeze the Z position, which is this blue axis here. And then for the freeze rotation, we don't want to be able to have him rolling over like that. We don't want him to be able to rotate around the Z axis, which is the depth-wise. So Z we block. And let's try it again. Now he's sliding left and right, so that's good. We still need to make him walk and face the right direction, but we're on a good path here. As you can see now, we don't want him to rotate like this either. So we can in fact freeze all rotations because we'll be taking care of this in the script. Okay, let's make him face in the correct direction now. Let's go back into our script. Let's call this one movement, so you know that one. And then let's call this, let's do something about the facing rotation now. And here we need to do again with a rigid body. And now we do a move rotation, which is the way to tell a rigid body how to rotate and still take into account the backend physics of Unity. You could just set the transform rotation, but the recommended way to do it for rigid bodies is to use the move rotation method. And for this, we need to do a quaternion, which is the rotation, and we need to calculate the Euler, and we'll create a new vector here. And the x component is 0, and then around the y-axis, which is up and down, we need to do 90 degrees, and then we'll need to do mathf, and then sine. Sine is going to give you either -1 or +1, and we need to calculate here. So we'll do, let's see now, I'm going to use mouse aim actually as well. I always want him to face in the direction where you're aiming, because the whole goal of this tutorial is to make the IK aiming. So what I'll do here is I'm going to put some code in that won't run just yet, but I'll fix that in a second. Here I want to be putting something called a target transform position X, which is the position of my mouse cursor in the X and Y, in the X direction, left and right. And then I want to do minus this transforms position X, so I know if it's to the left or right of me. And then for Z we want 0. And this one's red now because we haven't defined this. So let's create here. Let's do, we can do it so it's visible. Let's do public transform targets transform. And it's got no reference at the moment, but the code will work now. So again, if I press play now, nothing will really happen yet. It says that it's not been assigned yet, which it hasn't. We can actually create a new one here. Let's call this one, let's create an empty here, target transform. And for this one, you could actually put the crosshair, for example, or a sprite or something like that. I'll just keep it as a blank object for now. So let's just drag this target transform to here. Oh, I got 2 cowboy scripts. Sorry about that. Don't have 2 scripts. There we go. So as you can see now, he's facing where the target transform is, which is in the center of the screen. I haven't implemented mouse aiming yet. So as you can see, he's going to be facing where the target transform is. And we're going to change this. We can actually change this now so it follows the mouse. And to do that, we need to have a reference to the main camera. And let's do main camera equals camera.main. And again, the reason why I don't do this in the update loop is because calling camera.main is quite expensive as well, performance-wise. It'll find the camera every time in the scene. So if you have a lot of objects, it's unnecessary. So let's just put a reference into this main camera here. And then we need to do some ray casting here. So in the update loop here, I'm going to create a ray. So from the main camera, we want to do it screen point to ray input mouse position. And then we want to do a ray cast hit. I'll explain this in a second now. And then we want to do if physics ray cast ray that we just defined out that to a hit, and then mathf, let's send this to infinity and beyond. To infinity and beyond. I haven't watched was it Toy Story? I haven't watched that in a while. And then I also want to create a mouse, so let's create something called a mouse aim mask here. And this one's not defined yet. So there's a nifty shortcut here. If you press Control period, it'll suggest generate variable mouse aim mask. That'll save you some time. It saves you typing it by manually. So, but actually I want to change this from an int to a layer mask. And we want to make it public instead. So I could have typed that anyway. And if this raycast hits this one, I'll tell you in a second as well why we need this mouse mask here. But if this raycasts hit this, then we want to do target transform position should be equal to the hit position point. And this won't work just yet, but it will work in a second. What we need to do now is create a new object. So I'll create an empty. put this at 0, 0, 0 in the scene, and let's call this one mouse invisible mouse target, like this. And then let's create a new layer here and call it mouse target. And let's assign this layer to this object here. And the reason why is because now we can go into the cowboy here, and I can set this mask here to just be the mouse target. And for that, finally, we also need a box collider, and we want this one to be really wide, so 1000 for example, as you can see, and then 1000 high, and then we need to position it at 0.5. Actually, let's make it small again so you can see. So if you can see now that this front face is now right in the center of the screen. Usually you want all the bullets and everything to take place in the center of the screen of a 2.5 platformer, or in the center of the depth-wise anyway. So let's keep everything at 0 in the Z position. So that means that I've got to put this target collider here, so that this part of it, if I'm looking from the front here, will hit that particular point. So now if I make this one larger again, 1000 by 1000, then this mouse target now should, in theory, work. Oh yeah, here's an important point as well. My character stopped being able to walk now, left and right, even though it was working before. And that's because we've got this big massive collider here. And that's why we put it on a separate layer like this, because now we need to go into the project settings here. And then in physics, we need to disable all the collisions for the mouse target layer. And now we should be able to move again, because we only want to use this layer for the actual mouse position target here. And now you can see that when I move the mouse, he'll flip left and right, depending if I'm aiming to the right of him, or if I'm flipping, or if I'm aiming to the left of him. So if I move here, you can see that everything's working. He's sliding, good skater. Let's make him walk now. So we need to do the walk animation. And for that, I need to go back into the animator here. And let's drag these in. We'll put the walk animation in here. Call it walk forward. And then we transition from the idle and back. I right click here and do make transition. We need to also create a parameter here, and let's call a float, let's call it speed. Because we need to transition to the walk forward if the speed, so press that plus there, is greater than 0.01. And then I want to transition back to idle if the speed is less than 0.01. And here's an important one as well. We need to click out this has exit time, because we don't necessarily care about a walk cycle finishing. So let's deselect exit time, and as soon as the speed drops below that threshold, then it should transition immediately back to idle, back and forth. We haven't told the animator anything about this speed yet, so let's so nothing's going to happen if I press play now. But we go back into this cowboy script, and if you remember, we changed the velocity here. Let's put a little thing here. So we'll put animator, we'll set the float, and we called it speed. And then we want to do it the rigid body velocity, and we want to do the x velocity divided by the walk speed. That'll basically give it between a value between 0 and 1. Okay, let's press play. Here we go. Okay, we've got some funky stuff going on. He's walking up in the sky. First thing I see is that I'm not looping the position here, so let's do that. Let's fix that. The walk cycle here, we need to loop time. And we need to bake these into pose like we did with the other one. The positions and rotations. And we want to make sure that we don't have root apply. The reason why it was going up in the sky is because we had apply root motion enabled. So that one has to come off, because we're not, in this video, I'm not using root motion. So now we should have, hopefully a bit better. Yeah, he's walking now. But if I reverse, he's not going anywhere. Well, he's going backwards, but he's not walking. So to keep it simple, I'm just going to reverse the animation if he walks that way. So let's duplicate this one, and let's just do similar here, but in this case, let's transition and then transition back to idle. Let's call this one walk backward. We don't want any exit time on these. And we need to add a condition here. So if speed is less than minus 0.01, then it should walk backwards. And if it's greater than minus 0.01, then you should walk that way. Okay. Okay, and now, and you can see that is walking this one, we can see it here, and then when I walk backward it's doing that one, but the walk cycle is still forward. And to fix that, we can actually just, we want to change the speed here anyway, so let's do here, let's multiply, let's use a multiplier here, speed, and here we're going to use a multiplier speed as well. So now it's walking backwards. You could probably create a new walk cycle for him walking backwards. It'd probably look a bit better, but for simplicity now, I'll just use the same one back and forth like this. Okay, now you can see that if I flip here, it's a bit incorrect because now he's doing a moonwalk and it's the opposite here. So we need to take care when he's aiming left and right. We need to tell the animator that we're facing a different direction. And to do that, we can modify the script a little bit. Let's create a little getter here that we can use for this. And let's call this one, actually, we can make it private. And it's going to be an integer called just facing sign. And for this one, we need to do a get. And then let's do some checking here. So perpendicular vector 3. We need to do a cross product here of the transforms forward with worlds forward. And then we can calculate the direction now. So we do a float direction equals, and that's going to be the vector 3 dot of the perpendicular towards dot product transform up of the character's up position. If this doesn't make any sense to you, it's a bit mathematics to just calculate if it's going to be on if it's facing left or right. So you can just copy it, rewrite this code, or if you want to reuse it, or you can look up how the math behind it works if you want. And then we need to return the actual sign value now. So if direction is greater than 0, then we return -1. If it's not, then we need to check if direction is less than 0. And if it is, return 1. And if it's neither, if it's not any of those, let's return 0. So this will check if this direction here is greater than 0, then we know that the sign is a minus, so -1 we return. If not, we check if it's less than 0, then we know it's going to be facing the other direction, which is returning the sign 1. And this condition shouldn't really happen, the 0, because that's going to be an error. We don't really want to ever have a 0. That's going to be, we have to check that one somehow. Never mind, and this is just a shorthand for if statements. Instead of nesting a bunch of if statements, basically this is a shorthand to write if statements. So it just returns the value. Okay, and we need to use this one down here now. So facing sign. And let's encapsulate this with some brackets to make sure. And now the character should take into consideration. So here the walk cycle now works and the animation is correct because we calculated if he's facing left or right. There's a lot of talking for a little piece of code. Okay, let's implement jumping as well. We need that. First of all, let's go in here and let's grab the input here. And let's check if get button down jump. Then we do Rigidbody's velocity equals a new vector 3. Rigidbody's velocity x, we want to keep that one. And here we're actually going to reset the velocity now. So we're keeping the x velocity of his movement left and right, but we're going to reset the y because we're going to set a new one. And that one we need to add a force here now. So let's do rigid body, add force. And we want to do vector 3 up, because usually you want to jump upwards. So let's do jump. And then we'll do some nifty calculations. So let's do the square root of the jump height times, okay, gravity, yeah, physics dot gravity. We need to take into account. And then for this one, we also need force mode. Oh. Velocity change. Okay, we got an error here. What's it saying? Oh yeah, it's because we want the y component of gravity. Oh yeah, first of all, we want it to be negative. With that piece of code now, he can start jumping, but he walks in the air, so we don't want to be able to do that. And if you remember before, we created a little thing called is grounded here, so let's start using that one. We can just simply add here if get button down and if is grounded is not true, then he will jump. That won't work straight away. We need to also calculate now if is grounded is set or not. And for that, we can add a little ground checker. Let's put that one here in the fixed update. Ground check is grounded, physics, and then there's something called check sphere, which overlaps a sphere into a position, and then ground check transform position, ground check radius, and then let's add a mask here as well. So let's do this. I'll add that in a second. Query trigger interaction. We want to ignore any triggers for this one. And let's press Control period here on the keyboard and generate this one. And for the ground mask, actually, we want to make this one public, and we want to change it to a layer mask. And let's move it up here for tidiness. And now, like we did before, similar, let's create a new. Let's create a new layer here called ground. And let's assign this one to the ground layer, this floor one. And then we also need to go back to the cowboy here and then set the ground mask to ground. So you can add more in that layer mask. You can, if you should be able to walk on other things than the ground, like other objects or things like that, put them in the same layer mask here. So this is the layer mask that you change then. Okay. And now he can't jump. He can never jump down. So let's check why that is. Obviously, he can jump if he is grounded, not if he's not if he isn't grounded. So let's fix that. So if input get button down jump and the character is grounded, then he can jump. Phew, there we go. So now he can't jump in the air, like double jump now, but he's still walking in the air. I'm walking in the air. You seen that film with the snowman? You should check that out, it's quite nice. It's nice for Christmas, if you haven't seen that one. So we need to fix this now. So with the jump here, we did this is grounded. We also need to tell the animator this. So let's do animator set bool. Let's call this one is grounded. Is grounded, and let's set it to the is grounded variable here. And we also need to go into the animator and add this one, which is going to be a bool, and it's going to be called is grounded. And then we need to change that condition here that it can only transition into this here if is grounded is true. Same for the backwards. It can only go here if is grounded is true. And then here, from any state, let's make a transition to idle if is grounded is false. That'll basically force him into the idle state if he's in the air. So I won't be doing any more details for this one, but what you ideally should do, instead of using the idle state, you should really have a cross-fading falling animation so that he'll basically raise his arms as he falls faster and faster. I'll put a little screenshot here or a little video clip up in the corner so you can see how it looks in my game when I do it. But for the purpose of this tutorial, I won't be doing that. I can do a separate tutorial on the jumping mechanic if you want to have this blend tree of the falling animation. So give me a shout in the comment if you want to see that in another video. He's aiming left and right. He's walking left and right. And when he walks past the aiming point, he'll flip and start walking backwards. Whether you want it like that, it's up to you. Maybe you want to walk, maybe you don't want that, but since I'm going to be using mouse aiming, that's the whole purpose of this demo, so that's why I'm going to have him flip left and right. Okay, we've finally got to the aiming, the IK now. So we need to use some, let's create a new layer here and call it upper body. So we're going to create an avatar mask. So let's create a new folder and call it avatar mask. Let's create a new avatar mask and call it cowboy mask. And for this one, we want to disable the right arm and the head because we want to use IK for controlling the arm and the head movement towards the target. And for the base layer, let's do IK pass and then put this cowboy mask there. And since we've got IK pass on the animator now, there's going to be a new mono behavior that's getting called, and that's called, here we go, on animator IK. And we don't really need the layer index here, so we can take that one away. And then here, let's do the weapon aim at target IK. And here we do animator set IK position weight. Avatar IK goal dot, and we want to use the right hand for this weapon. And let's set this weight to 1, which is full weight. We want to have all the IK that we can get. And then animator, we do set IK position, avatar IK goal, right hand we want to use again. And this time, remember the target transforms, and let's grab the position for that one. So now if we press play, he's moving, he's aiming left and right. He's not so happy with the with the ground. He's in the floor, so we need to fix that. And that is because we need to set these. So weight is 1, and this one needs to be weight 1 as well. So we need full weight on both, and this one is set to override for blending. So now he's walking. So now we've got the hand moving. So at this target transform, you can see this one is actually moving here as I move it. It's an invisible object, so you can't really see it, but there is an object here, and we can prove that by, let's put a little object here, 3D object sphere here, a tiny one. And if you can see now, you can see that that little sphere is, oh, let's make it a bit bigger so you can see. Here, now you can actually see where he's aiming. So this little ball here. Let's take away the sphere collider. We don't really want it to collide here. So you could have a crosshair there, for example, a sprite with a crosshair if you want to have that. And then you could hide there's a way to hide the cursor, the default Windows one. So you could use that one if you just want a crosshair instead. Or you could hide it all completely. We also want him to look, it'd be quite skillful if you just shot like that. Well, let's make him look at the target as well. So for this one, in the same on animator IK here, we can do, so let's call this one look at target IK, and then same, we need the animator, and then set look at weight. We'll set that one to 1, so full, and then animator set look at position. Again, we want him to look at the target transforms position. That's all we really need here. And now he's also looking in the same way he's aiming. The IK is only affecting now, according to the layer mask there and the IK pass, it's only, and we're only using IK now, inverse kinematics, for the hand position and the aiming. and also the look at target, so the head here. And when he aims up in the sky here, he'll flip over and start aiming down here. So this is going to be quite a long video, I guess, but let's finish off as well with him being able to shoot some bullets and also have some recoil. That we have to do procedurally, because we want to have the recoil calculated after the IK is applied. Then we want to do the recoil. So you can't really use a normal animation for that you've modeled in Blender, for example. So we'll do that here. So first of all, again, look in the description if you want to skip forward straight to the recoil bit, but I'll have him shoot a bullet first. So let's just create a very basic bullet here. Let's create a new game object called bullet. And let's create a script here called bullet as well that we assign onto this one. Oh, it's 3:15 in the morning. I should get to bed soon. Okay. And let's add a component here, and we want a trail render. And let's add also a little bullet. Let's just do a sphere for now. Really tiny one, 0.05. And then we need to create a material here called trail, bullets trail. Let's do a particle unlit, and let's make this one gray, and let's make it additive. Here we go. And for the bullet here, we want to disable shadows, shouldn't cast or receive shadows. And then for the trail render, if I didn't add that one, did I not? No. Trail render, we want to have the initial size quite small, like so, and then end size should be 0. We don't want, oh yeah, we can fade it to alpha 0 and black. It's additive, so it's the black that's important, not the color. So everything else here is fine. We don't want to do shadows. It's unnecessary for that one, but we do want to assign the bullet trail material there. So this by itself won't really do much. We also need to be able to make the bullet move here. And for that, we need to set up a few variables again. So public float velocity, maybe 20. Public life is going to be 1 second, the bullets live. And then we have to take into account which layer fired it. Because we don't want the bullets to collide with yourself necessarily when you shoot it. And then we also need to have a float with a lifetime timer, so we can keep track of when it was fired. And let's create a public method here called fire. And we want to grab a vector3 position where it was fired, and vector3 Euler angle, and a layer that was fired from. And then the life timer, we want to set to time, so basically that's a timestamp. The transform position we set to the position that was supplied. So, and the Euler angles set to the Eulers that we supplied, and the position And the reason why I do this is because I want to reset the position. So we want to have the Z component to 0, because we want the bullet to always be fired in the center. Remember, we have just no depth basically, and enemies are going to be hit. We don't want bullets flying next to objects, either to the left or right. So let's force the Z component to 0. That's why I force that here when the bullet is spawned. Also, I'm going to instantiate these bullets, and normally you'd use a pool instead. I'll create another tutorial on that as well, about object pooling, but it would be way too big to go through pooling in this video, so I'll leave that out for now. But that's why this is a little bit prep for pooling objects, so there's a slight bit of extra code here possibly. We need to calculate a variable here as well, which is a projection on the plane. Project on plane, and then the objects transform forward with vector 3 forward. And the transforms forward now needs to be the projected one. And then finally, we need to do the look rotation for the bullet. To the projected one with vector 3 forward. I won't go through this code in detail. It'll take some time to explain, but basically it's a way to make sure that the bullets are going to be flying in the 0 position, and they're going to face in the right direction. Based on the aiming IK, we're going to submit in which direction the bullet should fly. And this is a bit of piece of code that helps that calculation take place. So I won't have time to go through it, but if you copy and write this one, it should hopefully work. Okay, and in the update loop, we need to make sure if the bullet hits something. So to do that, we need to do a raycast. So we do raycast hit, and if raycast, so transform position to and the direction is transform the bullet's forward direction. We're going to out that into the hit variable, and then we're going to calculate how far we're going to check, and it's going to be velocity times time delta time, so how long the bullet travels in one frame. And then we want to do a layer checking here to make sure that the layer is not the fired by layer, which I've also misspelled. And this is to prevent the bullet from hitting the gun that it was fired from. That's why I do this layer mask here. And then we do transform position equals hit position, because when the bullet impacts, if we calculate here, the bullets can fly really fast. So the raycast will make sure that it doesn't go through the object. It'll check where the next frame's position is going to be, and it'll do a raycast. And if it hits the object within that period of time, then it's going to trigger a hit. But we need to move the bullet so it doesn't create an explosion or whatever impact effect you might have ahead of the object. So that's why I'm forcing the position out to the hit point. That's the whole purpose of this piece of code there. And then we can do some calculations here as well that might be useful for you. And that's the reflected vector. Vector 3 reflect. The objects transform forward with a hit normal. And that's forward. And this one I won't be using in this demo, but it's really useful to have this one if you want to have sparks. If you have a bullet that hits a wall, and you want sparks to fly like a ricochet type of thing, then you can use this reflected, this is the direction of that reflection. We also calculate the direction, which is the transforms forward. And then we do another projection on plane here, vector 3 project on plane. And then reflected this time forward, and then we do transform forward equals the projected forward, and transform rotation quaternion look rotation vector. So this is similar to the code that I had before. When I did my platforming game, I had some issues with when I forced the bullet to fly in a certain direction and getting the reflection and everything correct. That's why I found out, or I introduced this piece of code, and that'll help the bullets to fly in the direction that you want them to and hit and calculate all the reflections and things like that. So if you don't understand this fully out, don't worry about it. It takes your head a bit of getting used to, and to be honest, I can't hardly remember it myself how I came up with this, but it works for my purpose. Probably the worst comments ever in a tutorial, I think. Okay, and let's create a method called hit, and then let's do transform position, and let's submit the direction, reflected, and the hit collider as well. Generate method, control period I pressed there, that'll automatically generate this method. And here basically what you can do here is do something here with the object that was hit, and you can access that one with the collider. So if you use, so example given collider.game object, and then you can either destroy it, for example, using this reference here. I won't be using that in this demo here or in this tutorial. The only thing that I'm going to do now is destroy the bullet itself. So destroy this game object if the bullet hits something. Oh yeah, we also need to make the bullet expire, and we also need to translate the bullet. So here, if there wasn't a hit, then we need to translate the bullet forward. So let's put else here and then do transform, translate, and then we do it in the vector 3 forward direction times the velocity of the bullet times time.delta time, because now we're not using a rigid body, we're doing it every frame. We need to multiply it by time delta time to make it frame rate independent. And then finally we need to do a check here as well. Okay, and we're back. Ran out of battery and the memory card, so let's continue. Sorry about that. Not that you noticed anything, it just went like that fast, I guess. Okay, the last thing we needed to do here is to expire this object. So if the time is greater than timestamp life timer plus life, plus life, then we destroy this game object as well. Game object. There we go. A lot of code for this bullet here, but now it's finished finally. The bullet itself is finished, but we also need to fire the bullet. So let's go back into Cowboy, and here in the update loop here, we need to do if input get button down fire 1, which is the left mouse button. We call a method called fire, and then we generate this one. First of all, let's instantiate the bullet. So we'll create a reference to a game object, and we instantiate something called a bullet prefab. And we need to generate control period here, and then generate, no, we don't want to control period and generate a field, which will be up here now. Game object instead. And then we actually need to create this into a prefab. So the bullet that we have here, let's drag this one. It's here called prefabs, a new folder, and then drag this one into there to create a prefab. We can delete it from the scene, and on Cowboy here now we have we should have a bullet prefab here. No, we don't yet. Oh yeah, it needs to be public, so you can see it in the inspector. Oh yeah, we were meant to drag that one to there. I'm starting to make mistakes now. Even though it's only 3:51 AM, I'm still doing mistakes. I wonder why. Cowboy, let's bring this bullet home. So in the prefabs folder here now, we can find the bullet and then do that one. So now we'll instantiate the bullet when we press fire, but we also need to do some more with this bullet. We need to set the position for it. And then here we're actually going to create something called a muzzle transform. And similar to what we did here, let's do public transform muzzle transform, because we want to know where the muzzle of the gun is, the revolver here. So if I go back to here now, we can expand this. I hold the Alt key and click here. So I expand the whole hierarchy. And then we find the gun here and we create a new object, create empty. I'm going to call it muzzle. And we double click on this one to find it in the scene. And then we need to just move this to the tip here of the pistol. This is where the bullet is going to come from. And it's important that this blue arrow here, the Z-axis, is pointing in the same direction as the gun itself. And when we've got that sorted, we need to drag this muzzle onto the muzzle transform. It's not appearing yet. It's because we've got an error. And it's because we need this one's position and not the object itself. And now it should appear here. There. So let's drag this one onto there. So now we can actually position the bullet at the tip of the pistol's barrel. And then we need to grab the reference here to the script that we created. So the game object will have, the prefab that we instantiated will have this component on it that we created, which is the script. And then we also need to call this, so bullet.fire. And then we set the position will be the transforms position of the bullet itself, since we've already set it. And then the direction will be the Euler angles of the muzzle that we created. And then the game object layer is the layer of the player itself. So that should be it. No. And now the guy should be shooting some bullets here, hopefully. Okay, we got some issues with the trail renderer. Oh yeah, I think, did I add 2 trail renders by mistake? Oh, it's because it's on the sphere. Ha, okay, so my bad. No, well, it's way too long, the trail render, so let's do 0.05. It's still a bit too big, so let's make it smaller. And whether you want a trail or not, that's fine as well. But now he's shooting in the direction. So the final thing, the final thing, the final countdown, the final thing, final. God, fed up with myself. Okay, so the final thing we're going to do now is just doing the recoil of the gun, of the pistol itself. So finally, that's not actually much of a code. So in the cowboy script here, we need a few more variables to set up. So here in the public section, we'll do public. And let's create an animation curve. Call it recoil curve. And then we need to create the duration of the recoil. So recoil duration equals maybe 0.25 seconds. And then we need to calculate or say the max rotation of the recoil. I'm going to just do recoil with the lower arm now. So when he shoots, it's going to recoil the lower arm. You could go full Monty and do recoil with the shoulders and the hands and everything like that, but it'll follow the same principle. So I'll just do the recoil now with just the lower arm, so you know. And for that one, we'll do recoil max rotation equals 45 degrees. And then we need to do some reference here as well. Public right lower arm. We need, oh, it's gonna float. And also the hand, right hand. And then we need to actually assign these here. So if we have our object here, the cowboy, we need to grab these references. So right lower arm is this one in the armature, and the hand is this one. Okay, we've got those. And now we need to create a little bit of code here as well. And it's going to be on this fire one. Before we fire the bullet, let's set the recoil timer to time.time, and we haven't actually created that one yet, so control period on the keyboard and generate field, and that's a float, which is fine. And here when we fire now, we set the timer here, the recoil timer, to time, and then we finally need to add this one as well, which is add the mono behavior, which is late update. And here I need to do some coding, so it'll be recoil animation comes here. So if the recoil timer is less than 0, we don't have to do anything here. So we'll just return then. That'll exit this late update loop. We don't need to do it. It's important to do this in late update as well, because the inverse kinematics will always aim in the direction, but we add the animation in the late update, which runs after the IK is applied, so we can modify the position here. So we need to calculate, since the recoil timer is running that we set in here in the fire method, then we know that recoil should be animated. So let's calculate here the curve time, which is going to be the time.time minus recoil timer's timestamp, and then divide that by the recoil duration. Then we're going to get a value between 0 and 1 of the duration. So when it's 0, it'll be 0. When it's 0.25, which is the current duration of the recoil, it's going to be this value is going to be set to 1. And that's because we want to evaluate here. So if curve time is greater than 1, then we know we're finished with the animation. So then we can just reset the recoil timer to -1, so it won't run anymore. But if it isn't greater than 1, that means that equals. That means that we should animate the recoil. So here we do the right forearm, or sorry, the right lower arm, and we rotate this around vector 3 forward. And here we evaluate the recoil curve with a curve time, which is between 0 and 1, remember? We need to multiply this by the recoil max rotation, so 45 degrees at the moment. And then we need to rotate it around itself, so it's going to rotate around its own axis. Then what we need to do now is actually set the animation curve itself, and that's you can configure that one how you want. But for example, I think I've already just click on a default preset here, move it down to 0. It should start and end at 0. You can right click on these and edit the key to make sure that it is 0. Yeah, that's good. And then we just create a bump here. I double click there and create a bump here and then a slower return. So you can draw this curve as you wish for the recoil. Now basically it'll go up fast like this one, and it'll slowly lower the pistol as well after the recoil. So maybe something like this. Let's try it out. There we go. So you can modify that curve as you wish for the recoil if you want it more. If you want to increase the recoil, you could go all the way up to, let's say, 90 degrees. If you want a big. And you could also change the speed, for example, here of the recoil to 1 second for a really slow one. So, okay. Let's keep it at 0.25 and 45. I think that was pretty good. And then we can duplicate Control D here to duplicate this object, and then just make sure that you can jump up here as well. Let's make it a bit smaller, 10. Let's make sure he can jump up on this platform. Okay, here you see that he sticks onto the side, and I'm glad I did this one because you don't want to fall for that one. Let's create a new material here, a physics material, and let's set the friction combined to minimum and then 0 friction here. And then for the cowboy here on the collider, put the physics material that we created here onto this capsule collider, and let's call it 0 friction. And now he won't slide. And we can make the capsule radius a bit smaller as well because it was bumping a bit too. So 25, like this. Okay, and he can't jump up to that platform. Let's do 10. Okay, just increase. And let's move the camera up a little bit, like this. And then what I'll do as well is, if you look at my channel history, there's a little 4-pixel sky tutorial that I made. You can check up in the corner. Maybe I'll be able to put the link up here as well. So otherwise it'll be in the description as well. So what I'll do is I'll just drag in an asset for that. But what you can do is follow that tutorial. It's called 4-pixel sky or something like that. And then basically it's to go through to create this texture called 4-pixel sky and this material called 4-pixel sky. There. And then drag this one to there. Unlit texture. Then we can just create a new object here in the scene. And let's make a quad. Let's position it back here. Let's disable shadows and then make it really big, 1000 wide and maybe 200 high, and then assign the 4-pixel sky texture to this object. There you go. And then we can make it maybe a little bit less high. 50, 40. Okay, it's just a bit of a nicer sky for platformers like that. So I think, let's see, let's maximize this and play a little bit. So we've got our guy walking back and backwards. We've got our guy walking forward and back, left, right. We can shoot bullets. The bullets die as we hit something with the ray casting, and we've got the recoil, and we've got the aiming set as we did. It'll point in the direction, and he'll look in the right direction, and he'll shoot the gun. All right. So, woof. Okay, that turned out a little bit longer than planned, 4:06 a.m. in the morning here for me. But I hope I didn't forget anything now. All right, everyone, that was a bit of a long video, but we got through it in the end. Hopefully you didn't fall asleep, and hopefully it did give you some help on how to do the inverse kinematic or the IK aiming with the straight out of the box IK tools that you have with Unity. So it's really straightforward to get that hand pointing in the same direction as your weapon, and also having the head tilt up and down. It's pretty much prepped for that one to begin with. So this is set up for just a single-handed weapon, and you could either modify it yourself to accommodate a second hand if you want to have a rifle or something like that. Or again, put it in the comments if you want me to modify this one and do two-handed weapons as well. I guess that's going to be a follow-up question fairly fast. Don't forget to hit the like button if you like this video. It'll help me out a lot. And subscribe if you haven't already. I'd love to be able to add some more videos for you to watch. Keep making games. I hope you get really far into this. Have fun with Unity, make games, and until next time, have a very good day. Have a very good day, though. Good.